Okay, we're moving on to this group of problems 29 through 32, so let's go there. So we have this bonus pay for baseball team. Mariad Jacoby owns a minor league baseball team. Each time the team wins a game, he pays the 9 starting players, the manager, and 2 coaches bonuses, which are certain percentages of the regular salaries. The amounts paid are listed below. Use this distribution of bonuses for the exercises. So we want to find the mean, standard deviation, and how many bonuses amounts are within 1 standard deviation of the mean, and how many of the bonus amounts are within 2 standard deviations of the mean. So we can just set up our table and answer all these questions. And there are 12, so we're going to need 14, a table with 14 entries in it. So I'm going to make that one 7 in this one. That'll be a clone, so it's going to be 14 rows and 3 columns. This is our data. This is our deviation. This is our deviation squared. So let's write the numbers down, and we'll drop the $ for right now. And I guess these are in numerical order. Looks like it. Again, if you're doing these problems, you need to draw the tables out, have all the entries, or you're not going to get credit. Okay, so the average is going to be somewhere right in here, around 200. But if we go ahead and add these numbers together, so the sum of the numbers is 2,430 divided by 12, and you get 202.5, which is about right in the middle. These high ones kind of shifted a little bit. Okay, then we do the deviation. Let's just round off to 203. I'll just make the calculation easier. So so we take the number 80 minus 203, and we get a negative 123. 105 minus 203 is minus 98. 120 minus 203, negative 83. 175 minus 203, negative 28. 185 minus 203, negative 18. 190 minus 203 is negative 13. So we have 6 that are below the mean. This is going to be 2, 7, 12, 97, 117, 123, 22. So those are my deviations. What I did here is I was just looking at 203, so I knew that 203 is 2 less than, or 205 is 2 more. And I just 210 minus 203 is 7, blah blah blah. And so I did the last couple in my head just to save time. Okay, so now we need to square them. And the previous one we got small numbers. This one's we get large numbers, because they're the only time we have small numbers for the deviation squared, or not small numbers, but just whole numbers is, or relatively reasonable numbers is when their numbers are, you know, from 1 to 10 or something like that. But once you start squaring stuff, then you can end up with reasonably big numbers. Those two we can do in our head. That one I know we do that in my head, but the rest I'm going to have to do the calculator. Okay, so those are all the squares of the deviations, and I add these numbers together. And there's something wrong there. One of those numbers is wrong. This one here, because it's so much bigger. I squared 320 instead of 117. I'll put the answer down in just a second, but okay, I think I get 71,078. This one is 13,689. Okay, so now all we have to do is standard deviation is the square root of the sum of the squares of the deviations divided by the number of data points minus 1. So we take 71,078, divide that by 11, take the square root, and I end up at 80.4. So that's the standard deviation. So the mean is 203, the standard deviation is 80.4. It says how many bonus amounts are within one standard deviation. So if you think about that, the mean is 203, so that's the mean. We take minus 1s, we're going to take 203 and we're going to subtract 80.4. 203 minus 84, 80.4 is 123. And if we subtract two standard deviations, so we subtract it again, 80.4, we get 42, so that's down two standard deviations, then plus one standard deviation is 203 plus 80.4, which is 283, and plus two standard deviations, we add another 80.4 onto that, and we get 364. So between these two values, which are plus or minus one standard deviation, we've got one, this one's less, so 1, 2, 3, 4, 5, 6. This one's above, so they're going to be 6 plus or minus 1 standard deviation. Now, two standard deviations are these two numbers, and you can see that all of the numbers are between, so 12, there are 12 that are plus or minus 2 standard deviations, and that's most of the data is between plus or minus 2 standard deviations. Okay, so I'm going to stop there and we'll do another one for the next